Welcome to another Swift deep dive. The goal of this lesson is to really understand the Swift syntax behind functions with inputs. Our current problem is that when our xylophone key is pressed, we want to pass over the title of the button to our playSound function. To solve this problem, we have to learn about function parameters, arguments, and data types. Now, if you think back to the greeting function that we created earlier on, all it does is say hello. But what if we wanted it to do something slightly different every time? What if, say, we wanted it to greet whoever came to our house? So it would have to say hello Angela or hello Jack, depending on who's actually at the door. How can we pass the name of that person to the greeting function as an input? Well, this is how we might create a Swift function that can take an input. So that way, the input can be incorporated into the body of the function to do something different every time. In programming lingo, the input is called a parameter. And the parameter is a bit like a variable without a value. All we have to do to create it is to give it a name and then give it a data type. So here would be the name of a parameter, and then it would be a colon, and then the data type of that parameter. Previously, when we were creating variables or constants, we've kind of just ignored their data type. But in fact, every variable in Swift gets assigned a data type when it's created. This means that the variable can only hold data of a particular type. So in this case, we have a variable called Angela that's holding a int type data. So you could also create this like so. And here, after a colon, we specify the data type of the data that's going into this variable. Now, how come we were able to create our variable like this without assigning the data type? Well, Swift also has a capability called type inference, which means that it's able to infer the data type based on the data that you've put into the variable. So in this case, our data is a whole bunch of whole numbers, right? There's no decimal places and there's no text. So this is assigned the type or the data type of an int. Now, the thing about the data types are that they have to stay the same. So if you create a variable that's meant to hold integers, well, it can only ever hold integers in its entire lifetime. And if you try to fit a different type into the variable that holds integers, well, it's not going to fit. It's just like those children's toys, which you have to fit a particular shape through a particular hole. And if you try to fit a star through a square, then it's not going to work. Let's see Swift data types and type inference in action. Let's go ahead and create a new variable, and I'm going to call it my age, and I'm going to set it to equal 12. Now, in this case, because we made this variable my age store a piece of data that is a whole number, then my age actually gets assigned the data type of int. And we can confirm this by holding down the Option key and clicking on the name of our variable, and you can see that this is the data type that it managed to infer from our value right here. Remember that we can change the data that's stored inside a variable by simply setting it to equal a new piece of data. But we can never change its data type. So if I decided this was going to be equal to 3, then this is not going to work. It's going to give me an error, and it's going to say that cannot assign value of type string to type int. So my age is of type int. 3, this text here, is of type string. So there's a mismatch on this line right here. Now, if you change the data type of the variable when it was first created, then it wouldn't give you any errors. It would be able to accept a data type of string, but now if we hold down Alt and we click on this, it's now assigned a data type of string, and it can forever only hold string data. So this will now give us an error. Now, instead of letting Swift infer which data type we want, we can also assign it at the point where we create the variable. And to do that, we add a colon and then we specify the data type. So in this case, it would be a string. And all the data types start with a capital letter. So we could say it's a string, or we could say it has to hold an int. Now notice how the assigned data type will override whatever value you put in there. So this line has a complete mismatch and we get an error because this my age is of course of type int because that's what we said it would be. And then we try to make it hold a string or text data. So that doesn't work. It has to be matching with the data type we specified. So now that we've understood about these data types, let's go back to creating a function with an input. When we create our function, we specify the data type of the input that we're expecting. And when we call the function, we call the same function name, and then in between the round brackets, we specify the input, or in programming, it's called the argument. So the parameter is the name of the input. The argument is the value of the input that we actually pass over when we call or trigger the function. Let's create another function called greeting2, and this function is going to have an input parameter in between these round brackets. The input is going to be called who2greet, and it's not going to have a value, but it does need a data type. So the who2greet, which is the name of the person that this function has to incorporate, is going to be a string data type. And that's it. So this is almost like what we did for creating a variable, other than giving it a value, and we're not using that var keyword. Now we're planning ahead. When this greeting2 gets triggered, what do we want to happen? Well, we want to somehow incorporate this who2greet variable. So let's say that we had a printed message which just says hello, and then it says the hello to the who2greet. But of course, in order to insert a variable into our string, we have to use our string interpolation, and then we can write who2greet inside. So now if we call this function greeting2, you can see that it automatically inserts the name of our parameter, who2greet, and then here we've got a little placeholder to specify the value. And whatever we put in here is going to be assigned to this variable, and then it's going to be printed out right here. So let's put in a value of Angela. Now if I run all of my code and this line triggers, then it's going to print hello, and then it's going to add that name Angela. So that Angela got added in as the input when we called greeting2. So it moves to be the value of this parameter who2greet, and then it gets used inside the body of the function. Now try calling this greeting2 function that you've created with some different values and see what you get. So I could say greeting2, and I could say Jack Bauer. And now if we run our code, you'll see that it'll write, hello Angela, hello Jack Bauer. Our greeting function is no longer always doing the same thing anymore. Instead, it's adapting to whatever input we give it, and it's able to achieve different end outcomes. So even though once we've created a function, we can't really change what's going to happen with that function ever again, but we can still make it do different things as long as we provide different inputs. Functions with inputs vastly improve the reusability of our functions by providing parts that can be modified. So if you think back to the analogy of our housekeeping robot, it'd be really useless if it could only ever fetch milk. If we had an item to fetch input, then we can tell it to get bread one day and then newspapers the next day, and we can use that input within the body of the function. So now that you've seen how you can create functions with input and how you can call them later on, it's time to complete the functions2 coding exercise and complete that assignment.